Imagine two artificial intelligences. Call them Model A and Model B. They were built separately. They never spoke to each other. They were never connected in any way. And yet, in a real experiment that should unsettle you more than it probably will, a strange behavior from the first one silently appeared in the second, as if it had jumped across an invisible gap. Here is roughly what the researchers did. They took Model A and gave it a quirk, a hidden preference, something harmless like an inexplicable love for a particular animal. Then they used Model A to generate training data. But, and this is the crucial part, the data it generated had nothing to do with that quirk. We're talking about bland, dry material, lists of numbers, pure sequences with no mention of the animal, no hint of the preference, nothing a human reading it could ever connect to the secret trait. Then they took that dry, unrelated data and used it to train Model B, a completely separate system. And when they were done, Model B had somehow caught the same quirk. The same hidden preference, passed along through data that, on its surface, contained absolutely no trace of it. Nobody programmed it in. Nobody wrote it down. The trait crossed from one mind to another through a channel we couldn't even see. And if your stomach didn't just drop a little, let me explain why this quiet little experiment may be one of the most important warnings about the future of artificial intelligence that almost nobody is talking about. To understand why this matters so much, you have to understand a shift that's already happened quietly in how AI is built. In the early days, AI models learned almost entirely from human-made content. Text written by people, images taken by people, the vast record of human knowledge scraped from the internet. But there's a problem. The supply of high-quality, human-made data is limited, and the appetite of these models is essentially infinite. So the industry turned to a powerful shortcut: synthetic data. Instead of only learning from humans, newer models are increasingly trained, in part, on data generated by other AI models. One AI writes the textbook that another AI studies from. On top of that, there's a technique where a big, expensive model is used to teach a smaller, cheaper one, the small model learning to imitate the large one's outputs. Sufficient, it's cheap, and it's everywhere now. And here's the quiet consequence almost no one outside the field thinks about. We have built an ecosystem where AIs increasingly learn from other AIs. The machines have started teaching each other. And that completely changes the stakes of what we just saw, because if a hidden trait can pass from one model to another through bland, innocent-looking data, then this enormous web of AIs teaching AIs isn't just sharing knowledge. It might be sharing things we never intended and can't even detect. Let's go back to that trait that jumped, because the truly disturbing part isn't that it happened, it's how. When you and I learn something from a piece of writing, we learn from its meaning. The words carry the lesson, but these models don't just absorb meaning the way we do. They pick up on deep, subtle statistical patterns, the faint fingerprints a model leaves in everything it produces, far below the level of anything a human would notice. So when Model A generated those dry lists of numbers, it didn't just produce neutral data. It stamped its own hidden signature into the patterns of that data, invisibly. And when Model B trained on it, it didn't learn, "I love this animal." It learned to imitate the deep statistical style of Model A so faithfully that the hidden trait came along for the ride, smuggled in beneath the surface. Researchers have a name for this kind of thing: the idea that a model can transmit behavioral traits through data that looks completely unrelated to those traits. And the implication is genuinely unnerving. It means you cannot guarantee a training set is clean just by reading it. The dangerous lesson isn't in the words. It's hidden in the texture, in patterns no human eye can audit. You could inspect 1,000,000 lines of that data, find absolutely nothing wrong, and still be passing along a trait you never wanted, because the message isn't written in a language we can read. It's written in a language only the machines share. Now widen the lens, because there's a second, related danger that turns this from a lab curiosity into a slow, creeping risk for the entire system. Think about what happens when you photocopy a photocopy of a photocopy. Each generation looks a little worse. The crisp edges blur. the errors compound. Researchers have found that something disturbingly similar can happen to AI models trained on the output of previous AI models, a phenomenon often described as model collapse. When models learn primarily from data produced by other models generation after generation, they can begin to drift. Rare, unusual, but valuable knowledge at the edges gets quietly forgotten. The outputs become more uniform, more bland, more average, converging toward a kind of gray sameness. The model starts to forget the rich, weird, full diversity of real human expression and instead learns an echo of itself. Now combine that with the contagion we just talked about, and the picture gets genuinely concerning. We have an ecosystem where AIs train on AI-made data, where flaws and biases can pass invisibly between them, and where each generation risks drifting further from the messy, authentic human ground truth it started from. It's not just that mistakes can spread. It's that they can spread, compound, and become invisible, baked so deeply into the shared statistical style of the machines that no one can point to where they began. So let's put the whole thing together, because this is where it stops being an interesting experiment and starts looking like a genuine structural risk. Picture the internet today. It is being flooded right now with text and images generated by AI, and that flood is growing every single day. The next generation of AI models will be trained on that internet, which means they will be trained in large part on the output of the current generation of AI models. Now add the lesson from our experiment. Hidden traits, biases, and behaviors can travel through that content invisibly, even through material that looks perfectly innocent. Do you see the shape of the problem? We may be building a world where a single bias, a single flaw, a single subtle misalignment introduced into one influential model could quietly seep into the training data of the entire field, spreading from model to model, generation to generation like an epidemic. But it's an epidemic with a terrifying twist. There may be no way to trace patient zero, because the trait doesn't travel in words we can read or rules we can inspect. It travels in the hidden patterns the machines pass to each other. A future AI could end up with a strange bias, an odd blind spot, a baked-in behavior, and we might genuinely not be able to say where it came from or how to get it out because it was never written anywhere we can look. It would simply be in the water, everywhere, learned by everyone, owned by no one. So what do we actually do with this? I want to be careful here because the point is not that AI is some kind of disease or that any of this is happening on purpose. It isn't. These are emergent behaviors, strange, unintended consequences of how these systems learn, discovered by the very researchers trying to make them safer. And that's actually the hopeful part. The people who found this are the ones sounding the alarm, precisely so it can be understood and managed before it becomes a real crisis. But it leaves us with a profound and slightly vertiginous question about the road we're on. We are building a world increasingly shaped by AIs that learn from other AIs, a hall of mirrors, each one reflecting the last. And the deep lesson of cross-model contagion is that in a hall of mirrors, a single flaw doesn't stay in one place. It multiplies. It reflects from surface to surface until you can no longer tell which mirror it started in. The real challenge of the coming years may not be teaching machines what we want them to know. It may be making sure that, as they increasingly learn from each other, they don't all quietly drift toward the same hidden mistakes, and that we keep enough genuine, human, ground truth signal in the system that the reflection never fully replaces the real thing. Because once the machines are mostly learning from machines, the most important question won't be how smart they are. It will be, whose lessons are they really passing on? And can anyone still see them? So I'm curious what you think. In a world where AIs increasingly learn from each other, who should be responsible for keeping the water clean? Tell me in the comments. I read every single one.